If you have seen the previous episode, we have talked about the star clusters, and before that episode is about galaxies. So this is continuation of it. So if you want a good continuous flow, do watch in a series manner in the playlist. Don't skip any video anywhere. If something is okay to skip, I'll tell you. There are a few topics you can skip also. I'll tell you. And also, I'll not be speaking faster from now because I'm getting drained because of speaking faster. So let's start with the life cycle of the star, how stars are formed, and then there are two types of division in the stars during the star formation, which is more basically low and medium stars, see here, and then high mass or massive stars. We're going to talk about that. There will be a first giant star cloud which is called as a nebula, right? This is the nebula. As I told you, I have given the definition already. So you go there and watch what is a nebula first. So this nebulae or nebula is in it. The nebula collapses because of gravity, because of two types of things. So top down or bottom up. And then once the nebula collapse, I'll show you. See, I should show it here. This is top down, in which nebula collapses, or monolithic large gas cloud nebula collapses like this to form stars, and stars form galaxies. And there is one more bottom up theory how the galaxies form. Basically here it is about the small galaxies, not the large galaxies. So anyhow, this is a galaxy, and we are not talking about this in this video. We're going to talk about the stars. So I want to make the difference between a galaxy and a star. I mean, just simple small fast recap. Then this enters, once it start to collapse, it enters something called protostar phase. This is the formation of a star. It is not the death of a star, it is birth of a star. Once protostar phase starts, then it enters into T-Tauri phase. This T-Tauri phase is very much important phase. It takes more time, and maximum of stars still in T-Tauri phase. Then we'll divide the main sequence phase. This is the main sequence where there will be two types of stars. First one is a low and medium mass stars. Example, our very own sun is a low and medium mass star, basically average mass star. This star, and there is another type which is called high and massive, high mass or massive stars. Example, the very nearby Sirius. Sirius is a high mass or massive stars. That is what is an example. Sirius, you remember that that is a high mass or massive star. We can mention it anywhere in UPSC that Sirius is one of this kind of a star. So what it will do is, once in the old age, this will become a red giant. This will become a red giant. Our sun will become a red giant. So it will show the color of red, and it will be a bigger star, and it is a red giant. It is still in the main sequence, and then it becomes a red giant in old age, and then it will be the planetary nebulae will be given out of the star. We'll talk about this, and that becomes either a white dwarf or a black dwarf. We are going to in depth talk about every term here. Don't be afraid of the planetary nebulae or the white dwarf or the black dwarf. We are going to talk about in depth about them. So white dwarf and black dwarf we are going to talk anyhow, and then this particular thing that will be, our sun will become a red giant, but the Sirius will become a red supergiant. It is more bigger, and then this will be ending into supernova. Once supernova is done, the process of supernova is done, it might be a neutron star, it might be a black hole. There are multiple reasons why it will be a neutron star and why it will be a black hole. We are going to discuss about that. So this is the life cycle. We are going to talk about nebulae again. The gravitational collapse happens, as I told you before in the before video, and then starting stage of a star. Any star will start from the nebulae. This nebulae is what the main origin point of the star. So any star will start from here, then it will enter, as I told you, a protostar phase. This protostar phase, what is this phase is what I have written here. This is the formative stage of a star. This is the starting stage where the star forms. How it forms is nebulae will spin very rapidly, and then intense heat and pressure will be generated inside the nebulae. I'll draw it here for you. This is a nebulae, for example, consider. Then there will be intense heat and pressure because this started to rotate or spin very rapidly, and then intense heat and pressure generates because of spinning. As I told you before also in the previous episodes, that this nebulae will move very fast, so and also expand and cool down. That is a later stage. At this point of time, we are not going to talk about the expansion and cooling down and formation of planets. This is about how the stars form. So this will rotate, it will spin, and then this spinning gets the heat and more pressure, and the glass gas cloud further collapse and become smaller, 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 and smaller. When the temperature becomes 10 million kelvins, the hydrogen fusion can occur at 10 million Kelvin. Hydrogen fusion, what is this? This is a very new topic for you. I'll not explain this. You go and search on it. You will get the description what is hydrogen fusion. This is the thing you have to search and learn about hydrogen fusion, how it occurs, why it occurs. This is the temperature it occurs. Now, once the hydrogen is fused into helium, this is the conversion stage. This stage, the star is born. The star will be born here. A new star will be born here when the hydrogen fusion start to occur. That star born phase is called protostar. This stage of a star, I mean the nebula converting into a star, 10 million Kelvin, and then hydrogen fusion occurrence is the place where the star is born, and this particular step is called protostar phase. So, next, the T-Tauri phase. Before fusion, protostar goes through this phase. Before this fusion, hydrogen fusion, exactly at 10 million Kelvin, the any star will go to T-Tauri phase. We have named that stage, of course. All stars follow the same process. We have named that particular phase as T-Tauri phase. This T-Tauri phase um, is very much important phase. The core temperature is still low for hydrogen fusion, just before hydrogen fusion, that is in the T-Tauri phase. All star energy comes from the gravitational force only. As of now, there are no other forces, only gravitational force in the T-Tauri phase. Nuclear fusion starts and equilibrium is achieved. Opposing forces, basically, nuclear fusion will start. Nuclear fusion will start, and the heat is from gravitational force, and this is the initial stage, and then nuclear fusion will start to occur. Before that, everything will be in equilibrium. Matlab, there is no extra forces inside. There is only gravitational, nuclear force, and gravitational forces are in equilibrium. Star is considered to be in main sequence star. Now I'll tell you, you are not getting this. I understand that very much clearly. T-Tauri phase is just before protostar phase, and now once the nuclear fusion starts, just here you observe this nuclear fusion starts, then it is sent as main sequence phase. You got it? I hope you understand this. You rewatch it or read about it, you will get it. So what is the main sequence star phase? Here, basically, core of the star, anytime core of the star is capable of hydrogen fusion. Hydrogen fusion, it is capable. As I told you, 90% the star's life, 90% of the star's life will be in the main sequence star phase, main sequence phase. So for example, we'll take sun, the average mass star. Main sequence of sun of our very own sun will be for billions of years. It is not about 100 years, 200 years, no. It is about billions of years. It will be for billions of years. The sun will be in the main sequence stage. Main sequence stage, what is main sequence stage? The nuclear fusion started and others are in equilibrium. Everything is in equilibrium. Nuclear fusion started. Right now, even our sun is in main sequence stage. So now, smallest stars, whatever the smallest stars are there, red dwarfs burn hydrogen slowly. So none of them left this phase since the universe formation. So when it is a smallest star, the nuclear fusion occurs very slowly. So the red dwarfs, smallest stars, matlab red dwarfs, consider like this. These these are still in the nuclear fusion phase. So which means that main sequence phase. This main sequence phase is no small star in the universe till now left this phase. No small star. That slowly hydrogen is burned and helium is produced. Large stars like Sirius exit this phase only after few million years. Large stars, the nuclear fusion happens very fast and they leave the phase very soon. Hydrogen to helium. So basically, remember this, if hydrogen is exhausted, then it enters old age. Main sequence is done. Then once the main sequence is done, we enter into old age. Main sequence and then old age. Now let's see the difference between low or medium or average mass stars, which is sun, versus high mass stars, which is Sirius. So here we are going to differentiate in multiple ways. I'll show you the pictures later, but we have to see, as I told you, I have guaranteed you the flow. I mean, how the flow happens, we are going to talk in the similar way as this image. So here I have guaranteed you, I'll explain white dwarf, I'll explain black dwarf. Also, I have guaranteed you we are talking about neutron star and also black hole. So we are going to talk about this in this. How low or medium average star proceed further, how high mass stars proceed further. Red giants. So we are going to talk about red giants. Basically, star is in old age. Main sequence is done. Whether here main sequence is done. Now star is in old age. So what happens is nuclear radiation will be zero. It will be ceased. Nuclear radiation will be ceased because hydrogen is completely exhausted here. So star, what happens is star once again collapse because due to gravity. Before there was equilibrium. Before there was equilibrium. Now again the nuclear radiation is done, so gravity again starts to take charge. So again the sun will, or the star will collapse inside. Now hydrogen in the star's surrounding, whenever it collapses, na, for example this is there, then this is the surrounding, there will be hydrogen. If there is hydrogen, then that will start to burn. So outer layers expand. So once this starts burning, then this outer layer will start to expand. And once it expands, it doesn't produce as much as energy as nuclear radiation. This is because of gravity, right? So nuclear radiation produces hell lot of energy. Now this is because of gravity, just the hydrogen around the surrounding produces maybe not more than 2500 to 3500 Kelvin, not more than that. So less energy, so it looks like a red star. That is what happens. And even this is not about some thousands years or something like that. It will be also for billions of years, and up to 100 to 1000 times of our sun it will swell. So hydrogen and everything exists in the surrounding, so it will start to burn the surrounding but collapses inside, so the red will be emitted. So that is how the red star is formed when the average or medium mass stars done with their hydrogen fuel inside. Now we are going to talk about planetary nebulae. As I promised you, so we are going to do so that star expels outer layer of gas in explosion. As I told you, outer layer will be expelled. This particular expulsion, outer layer is expelled, and then surrounding of hydrogen um, will be start hydrogen from the surrounding will start to burn. In the similar way, there will be expulsion from the sun's outer layer. That is called planetary nebulae. Once that outer layer of hydrogen it is burnt, then the only inner part remains. This is white dwarf. This white dwarf will be completely white in color. We feel that it is white in color. So it is named as white dwarf. This is the core. Once outer layers of star are shredded, sorry. So here, if you observe, I have written this for you so that you understand better. Once outer layers of star are shredded, they are expelled out. Only core carbon and oxygen is left. That is called a white dwarf. So this is basically roughly size of Earth, pressure and condensation. These stars are scorching. So what is scorching? That is very, 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 very hot. It is not like white, so it is ice. No, it is very, 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 very hot. So they glow white. This is the core of the sun when the outer layers are sent away in the form of planetary nebula. Now we are going to talk about a black dwarf. This is an opposite term to the white dwarf. So let's see. Final stage in a life of a medium mass star like our sun, remnants of white dwarfs. What are remnants? They are leftover or the next stage. These are, we can consider the leftovers are next stage. These are remnants. So the remnants of white dwarf slowly cooling. This particular white dwarf will slowly cool and dim down to burn the remaining fuel. No black dwarfs from the beginning of the universe, as it takes a very long time. We have black dwarf here. This white dwarf should cool down and then will become a black dwarf, ultimately cool down. That is what I was talking about, remnants of white dwarfs, which means that the next stage of white dwarf, that is black dwarf. Black dwarfs, there is no single black dwarf from the beginning of the universe, because no white dwarfs got cooled down till now. So now let's know about the higher mass stars. High mass stars forms red supergiants. They are basically massive stars, for example 8 to 9 times of our sun. Nuclear fusion can occur even after helium hydrogen is exhausted. Stars can swell up to huge space. For example, sun to Jupiter, it is a very huge space, so they will swell that amount, that big amount. The surrounding hydrogen and helium is taken and then that is burnt. So this is a red supergiant instead of red simple giant. This is red giant, this is red supergiant, because it have huge area, it has huge diameter and huge circumference, so it swells more compared to the red giant. So now let's talk about supernova. This is very interesting topic and very important topic you have to learn. So now supernova is in such a stage where you observe the red supergiant gets into the death phase, death and remnants phase. When red supergiant enters the death and remnants phase, then the supernova is formed. We'll see what is supernova. So it is reached end of the life. The star collapses instantly under enormous gravity. Till now, there is equilibrium, even in the red supergiant. But once the surrounding hydrogen helium is also completed, now gravity will act, enormous gravity exerted on its heavy iron core. There is iron core in the red supergiants, and then it accumulates. Of course, it's nebula, it contains everything, but heavy iron will be there inside the high mass stars. When the red supergiant, the equilibrium is closed, equilibrium is broken, then the metal, the iron core inside will be, the gravity will act on iron core very hugely. Now, the core shrinks from around 5,000 miles. You consider 5,000 miles. Uh, in very fraction of seconds, it will collapse. It will collapse completely. That huge universal celestial bodies collapsing in seconds is a very big phenomena in the universe. So this collapse is nothing but a big explosion that is called supernova. That is called supernova. So whenever a red supergiant, the equilibrium in a red supergiant is broken, then enormous gravity exerts heavy pressure on the iron core inside the red supergiant. Then there happens an explosion which is named as supernova. These are brightest and violent events in the universe. Basically, this happens in very fraction of seconds, sometimes in couple of seconds. They sometimes outshine entire galaxies because iron is a metal, and the metal can't take heavy pressure. So that is what the supernova event is. Basically, it's an explosion. So I hope you understood what is supernova. Let's get into neutron star. What is a neutron star? Basically, the collapsing core which we have seen is 1.4 to 3 solar masses. What is a solar mass? Solar masses is again your work to search online. I have given the before work about the light year and now the solar mass. These are the definitions which you have to know compulsorily. If I tell you, you will forget it. So go and search so you will remember it. So if the collapsing core which we have talked about before, matlab iron core, if that is 1.4 to 3 solar masses, then that forms a neutron star. 1.4 to 3 solar masses. This thing happened, a supernova happened. Supernova, everything collapsed into the iron core. On the iron core, there is a uh, heavily exerted gravity. So there is an explosion. That explosion is supernova. And once the supernova, if the supernova happens on 1.4 to 3 solar masses core, I'm not talking about the red supergiant mass. I'm talking about the core mass. This core is 1.4 to 3 solar masses. Then there forms a neutron star, which is very highly dense, heavy, and a trim body. This is what a neutron star. And if it is greater than 3 solar masses, then and there forms a black hole. The force of gravity, which is broken in equilibrium, continuously, rigorously gets, it is unstoppable, and everything is dragged inside. I told you in red supergiant, I'll clear the concept once so you'll get it. In a red supergiant, whenever the equilibrium is broken, I mean the helium or hydrogen is exhausted, it should be, the red supergiant is already formed because hydrogen helium is exhausted, then it expands, taking the nearby hydrogen, nearby helium, or any other elements. And once the red supergiant is formed, the red supergiant, again once it is done with the helium and hydrogen, the nuclear radiation is done, then the equilibrium is broken. So the only force will be gravity. Because of this gravity, if the core of the red supergiant is iron, and the core of the is iron, and that iron will be coming under, due to breakage of that equilibrium, this iron core will be coming under heavy gravity. This heavy gravity, if the iron core is more than 3 solar masses, then this iron core will act as a black hole. If it is 1.4 to 3 solar masses, then it is a neutron star. If it is greater than 3 solar masses, then the gravity is so strong, nothing can escape the gravitational force at that point, even light. It pulls stars, it pulls planets, it pulls nebula, etc. Anything. So, as it doesn't even allow light to escape, that huge gravity exists in a black hole, it doesn't even allow light to escape from it. So, how do we identify a particular black hole? That is what I told here. We see them feeding on stellar matter. What is stellar matter? And what is binary stars? What is blue straggler stars? And what is other terms which we use in the space? This and all will be discussed in the next episode. I hope you understand this. If you don't understand, either put in 1.5 or put in 1 or 0.5, or do rewatch the whole episode again. You get to understand this. This is very important topic: supernova, black hole, neutron star, and then red giant, white dwarf, black dwarf. Everything is very much important in the universe chapter. Thank you so much for watching. If you have liked this video, I appreciate you. If you didn't like it, please do like it, share with others and everybody. Have a nice day.